Welcome back, everybody. In this final chapter of this tutorial, what we're going to do is we're going to go over that fast skin shader that we saw in one of the first videos of this tutorial. We're going to go over this skin shader. I'm going to show you how to use it, and we're going to see how it works and how to get it looking pretty good. So we're going to use an example scene to do this. So let's go ahead and open up an example scene here. And the scene you want to open up is called Jellyfish Start. So as the name suggests, what we're going to be doing here is rendering out a sort of underwater creature here, and here it is. So this is what our scene looks like here. All we have in this scene is this high-res jellyfish sort of character, the protagonist of our little render scene here. So you can see, in case you're wondering how it was modeled, the base mesh was modeled here, and then it was detailed in ZBrush 3, which is great for modeling these high-res type objects. And then we have this light over here, which is just a spotlight converted over to a mental ray area light. And if we open up the attribute editor here, you'll see that it does have a light effect property here, and what it has is light fog. Okay, and if I go ahead and I render this out, you'll see what we have here. There we go. So it's sort of this deep underwater scene inspiration. This sort of came out of those Discovery Channel episodes there when they go deep sea exploring. So I guess this light back here is a light coming off of one of those deep sea exploring submarines. And over here we have this deep undersea jellyfish that's a new species or something. So I just went online and checked out some reference images of different types of underwater sea creatures, and I thought a jellyfish would be a pretty cool thing to do here for subsurface scattering, as the subject of our subsurface scattering tutorial here. Okay, so right now this jellyfish here, if we go ahead and check out the material attributes, it's just using the default Lambert shader. Okay, and if we go ahead and open up the hyper shade here, you'll notice that all we have here is that Lambert 1 shader. What we need to do is create the shader for this object. Now, obviously, we're not going to be using a Lambert 1 shader. That's not going to work for this specific case. What we're going to need to do is use that mental ray skin shader that we saw in one of the earliest videos of this tutorial. If you remember when we were going over the shading models, I very quickly and vaguely introduced you to the skin shader. So now you're going to get to see it in action. Okay. So let's go ahead and let's create the skin shader. Let's just minimize the hypershade there. I'll right click on top of the jellyfish here, go to assign new material, and here in the mental ray section, which is this whole lower list over here, we're going to go and look for down here. You'll see a list of shaders that start with the word MISS, M-I-S-S-S, or mental images subsurface scattering. And what we have down here is the fast simple, and then we have the fast skin Maya. Okay, so fast simple Maya and fast skin Maya. We want to go with the fast skin Maya. That's the more complex out of the two shaders. Okay, and here's the new shader. Now, quick note. In the past, in previous versions of Maya, basically versions before this one, versions before Maya 2009, you used to have to set up this pretty complex shading network that was pretty much left to more advanced users, and you had to do this in a hypershade and make sure that you had a mental ray texture file and a light map, all this stuff hooked up together in a specific way, or else the skin shading effect wouldn't work. Fortunately, in Maya 2009, we no longer have to worry about that. If I go ahead and open up the hypershade here, and you can see the shader's not here, let's just switch over to the Textures tab and then go back to Materials tab, and it'll pop up here. It's just a refresh issue with Maya. We'll see that right here is by default, it's called the Miss Fast Skin Maya 1. So let's go ahead and right click on it and go to Graph Network. So it pops up here in the work area. And let's expand this work area down here. Let's actually select this shader here and click on the Input and Output Connections button right up here. Okay. So this is what we have. Now this is what it looks like so far. I went ahead and created this mental ray texture node here and plugged it in where it was supposed to for the skin shader here, the Maya skin shader. Okay. Like I said in the past, you had to do this manually, but now Maya 2009 takes care of this automatically for you. Okay, so here is the attribute editor window for the fast skin Maya shader. And as you can see, it's got a whole bunch of different parameters here. You can see this is a pretty big and complex shader. And that's because it has to do some complex shading. It's basically got to imitate the way that skin behaves when it interacts with lighting in your 3D scene. So this is a very realistic shader, but it also renders pretty fast. It's not a physically based shader, so it's not the most physically accurate shader, but it's so good that really it doesn't make a difference. The naked eye won't be able to tell if you were using skin shading or subsurface scattering with photons, or if you were using this fast skin shader. Okay, so let's go ahead and rename this shader. Let's rename the material here to Jellyfish Matte. Copy the name. Hit this output button over here. Let's go back to the shading group and let's rename the shading group here. There we go. Just keeping things nice and organized. And you can see here's this this light map. A light map's created whenever you create a one of these mental ray skin shaders. The light map's created. Also, what's created is this mental ray texture node over here. Now you can see that this area here for the for these two parameters, the file size and width, the file width and height, has this purple background here. That means that there's an expression tied into that parameter. If we click on this button here, we can see that there is an expression here, and there's the expression up there. Basically, the way it used to work was a bit complex because you have to set up different parameters here. For example, it depended on whatever render settings you have over here. If I go to, let me minimize that. Let me go back. Let's actually render this out just to see what we have. And there we go. Only took 9 seconds to do that. You can see it's kind of a grainy result, but don't worry about that. We'll be fixing that up soon. And you can see here the way that this thing looks. It looks kind of dark and grayish, but then in this area here, it appears almost as if there's some light coming in from behind it or inside of it, and that is actually the case. If your subsurface scattering is really evident in real life, if you take a flashlight and you cover the flashlight while it's on with your hand, you'll notice that the light still penetrates through your hand, and your hand turns into this sort of reddish color. That's subsurface scattering. That's kind of the effect that we have here with this jellyfish right now. So let me go to my render settings here just to show you something really quick. You notice that my image size is set to 640 by 480 down here. You notice that in the expression here for the mental ray texture parameter here, we have the width set to 1280 and the height set to 480, and they're being controlled by expressions. Basically, the way this works is the height has to be the same parameter as the height set here for the image size. So if the image size has a height of 480, which is the case here, then this file size height has to be 480. Now, because it's an expression, you notice that when I change this to say 320 by 240 in my render settings, the expression automatically updates the mental ray texture node over here. So now the size of the image went from 240 pixels in my render settings and changed to 240 here in the file size height inside of the attribute editor for the mental ray texture node, which is plugged into the skin shader. Okay, that's really important. Now you don't need to worry about why that's important, because in Maya 2009 all this stuff is automated. It's all done for you by expressions set up for you automatically. In the past, you had to know all of this stuff and you had to come in here and set all this stuff up. You also notice that the file size width also changes, but it's different. You notice that the width here in my render settings is 320 pixels, and here it's 640 pixels. Why is that? Well, that's just one of the requirements of the fast skin shader. This parameter here for the width has to be double the width of your render setting. So if my render setting for the width is 320, then my width here has to be 640, because 320 times 2 is 640. If I change this back to 640 by 480, you'll notice that it doubled. It went from 640 to 1280. So it's 640 times 2. And that's what you can see in this expression. If I go back to the expression here, notice that at the end here, it says default resolution width times 2 right there. It's a little bit difficult to see in the video, but you should be able to see it when you have Maya open, you're following along with this tutorial. Okay, So why does that happen? Why do you have to have this mental ray texture node plugged into the shader, and why in the world do you have to have the filter or the file size width and height set up based on what the file size is here in the render settings? Why is that? Well, that's just the way it works. There's no point in discussing why it is. That's just the way that it's going to work, and it won't work any other way. So that's just a requirement. Fortunately, though, you don't have to worry about this stuff because it's all done automatically for you. In the past, you had to do that manually. Now you don't. Okay? So I'm going to go ahead and close that attribute editor. I just want to show you that really quick so you kind of understand what's going on under the hood. But you don't have to worry about it. Again, it's all automatic. So why does this thing... Editor, edit that out of the video. There was a phone ringing in the background. Start again in 3, 2, 1. Editor, edit that out of the video. Starting again in 3, 2, 1. Okay, so we can see we have this subsurface scattering effect here. That's why this area looks pink. There's a light that's trying to come through. Now, that's not exactly the light that's coming here from this blue area. It's a light that I placed inside the jellyfish. So let me show you how it works. Let me close this. Let me go to wireframe mode. It's going to be a little bit difficult to see, but I'll zoom in here. And actually, you know what? Let me just take the jellyfish here and temporarily hide it. So I'll select the jellyfish and hit Control and H on the keyboard there. And you'll notice that there's a light here in the center. Let me remove the grid. I'm going to go up here to my viewport shading options up here. You notice there's a little grid icon here, and it says grid and tooltip when you hover over it with the mouse. Just go ahead and click on that to turn the grid off. You notice this one's called Jellyfish Light. If I go ahead and open that up, it's just a simple point light here with some basic intensities and color and stuff like that. It's got this bluish color. And that light is inside of the jellyfish. Now, when I was doing my research here and I modeled this jellyfish out, I found that there's a lot of different species of jellyfish, and the one that really caught my attention, I saw several species of jellyfish that sort of can create their own lights, if you believe it or not. Editor, edit that out of the video. There was a phone again in the background. Starting again in 3, 2, 1. And one type of jellyfish that really caught my attention is, actually there's many different species of jellyfish that can do this, but there's a lot of jellyfish out there that can actually create their own light sources from within their bodies. It's actually pretty amazing. And so I wanted to imitate something like that. So using a subsurface scattering shader, you can do that. If you just place a light inside the object, the light will actually interact with the subsurface scattering shader and create a pretty neat effect, which is why we were able to see that pinkish kind of color there inside the subsurface scattering shader, because this light is inside the jellyfish. Okay, so I'm going to hit undo a couple of times to bring back my jellyfish. There it is. Okay, so now that you know where that light was coming from, so later you don't think, where's this mysterious light coming from inside the jellyfish? Now you know. Let's go ahead and let's set up this shader. So I'll go back to the hyper shading. Here's my skin shader. Let's open it up. Let me hide the hyper shade there for the moment. Okay, so we have these different parameters here. We have this diffuse layer. We have this diffuse layer set of parameters. So we have an ambient parameter, overall color, diffuse color, and diffuse weight right here. Okay, now these things are going to control the overall color of the shader. So basically anything that's on a surface, say little spots, specific little texture details like maybe some dirt or some pigments, whatever you want basically to be on the top of the surface. In fact, even if you had say a character with a tattoo, you want to make sure that your texture with the tattoo is placed here in the diffuse layer set of parameters. Now, there's a lot of ways you can hook this stuff up together. There's no one way to do this, so I'm just going to show you my way of doing it, simply because there's no one specific rule as to how you do this. Say if you had a texture of a tattoo for a character, you could put that texture in the overall color and the diffuse color. You can stick it just in the overall color or just in the diffuse color. You can put it in the ambient, overall, diffuse. Basically, it depends on the look you're going for and how your shader's rendering out. So it's really scene dependent, and it depends on what your artistic vision of the scene is. So that's really important to know. In this case, I'm going to be showing you my way and how I'm going to get it done for this specific scene of the jellyfish, which will have different settings here for the shader, which won't work for every single circumstance. So if you're working on some kind of character or something, the settings I use here probably won't work for that character. So these settings that I'm going to use are going to work specific for this jellyfish object right here. So you want to keep that in mind. Alright, so down here we have the subsurface scattering layers, and we have a whole bunch of parameters. Basically, we have a section here for the epidermal layer of skin, the subdermal layer of skin, which is the layers of skin that go underneath the epidermal layer of skin. And then we have the backscatter, and the backscatter is the part of the skin at the back where the light's going to exit through. Okay, so we have all these different parameters. If you're not familiar with what epidermal or subdermal or any of that stuff means, I strongly recommend that you do a little bit of research when you get some time. Maybe do a Google search and whatnot, or get a book and have a look and see what this epidermal and subdermal stuff is, because you don't have to be a doctor and you don't have to be a dermatologist to know what this stuff is and how it relates to human skin, but it actually would be very useful information, so you have a better overall understanding of what's going on here and how this shader works. Believe it or not, despite the fact this is computer animation, some knowledge in the medical field that relates to the way that skin works can actually be pretty useful for when you're working on something like this. Just like if you're a character artist, it's a given. You have to know about anatomy. You have to study anatomy. You have to be very familiar with anatomy in order to be able to be a successful and very skilled character artist in the computer animation field. And anatomy has nothing to do with computer animation. It has to do only with the medical field. So there you go, another example of how something completely unrelated from another field can actually relate and come into play and help you out when working in computer animation. So now here we have our specularity parameters. These parameters are going to control things like reflections and the shininess and stuff like that, as well as Fresnel reflections on the jellyfish character here. Okay, then we can apply bump shader. We have a light map control, and I'll talk about that a little bit later. And we can also control the algorithm here, and I'll talk about that later as well. Okay, so I'm going to end this video here, and in the next video we'll start plugging in our textures and adjusting these settings here and doing some test renderings so you can see how this shader works and we can get to a final result.